up till now we have solved up till factorial of a large number. Let us try solving the find maximum product subarray problem today. So what does the problem say? The problem says that you have been given an array of integers and you have to return the maximum product possible for any subarray of the given array. Okay. I hope you all know what is the meaning of a subarray, but for safety purposes I am mentioning it again. A subarray is any contiguous part of an array. Contiguous part of an array. Like for the given example, what are the possible subarrays? So the possible subarrays are this one, after that this one, after that this one, then this one, then this one, then this one. After that it will start from 3, only 3, 3 and minus 4, 3 and 2 up till 3 and 6. After that it will start from minus 4 and go up till 6. After that it will start from 2 and so on. And the last subarray we will have is only 6. Okay. So I believe that you have got the hang of what is a subarray. Okay. Now we have to provide maximum product. Okay. So what is the brute force? The brute force approach. Okay. As you can see it is mentioned here subarray. And in all the previous videos, I have mentioned that whenever you encounter a subarray, the brute force approach remains same. That make all the subarrays and do the required operations and return the answer. Okay. If you haven't watched, please watch the videos so that you get a better hang of it. Else, I'm explaining how to form the subarrays here also. So, to form the subarrays, what you should do, you should start in a loop from 0 going up till n. So the given array was 2, 3, minus 2, 4, minus 1, 6, right? Correct. So first our I would be here, then here, then here, then here, then here, then here. Correct? Now, as you saw that we had to get 2, then 2, 3, then 2, 3 minus 2, then 2, 3 minus 2, 4, up to 2, 3 minus 2, 4, minus 1, 6. So what we were doing, first our pointer was lying here only, then here, then here, then here, then here, then here. When I was at 3, our pointer was starting from 3 and going up till 6. So what we can do, our j would be starting from the position with the I and will go up till the last element, that is n, j plus plus. Alright. Now we had to calculate the maximum sum. So for that, what we can do, we can start a loop from I to j for k equals to 0, k equals to I, k will move up to j, k plus plus. Now to calculate product, what we can do, we can keep a variable product here which is equals to 1 correct currently, and prod will become prod star array of kth index. Correct? At last, keep a maxi here which is currently int main. This will be our final answer. And after the kth loop, the subarray has been resolved, and maxi will become max of the existing maxi with the currently evaluated prod. Okay. After that, after both the loops have ended, what you can do, you can return maxi. Return maxi. I hope it was clear to you. So what is the time complexity in this case? The time complexity, as you can see, that this operation will take n terms, and this operation will operate n times. This will operate nearly n times, and this will also operate nearly n times. So it will be O of n cube, and space complexity is O of 1 as usual. Okay, but if you realize O of n cube is not that efficient, it is very much what do we say? It is very much delay. Yeah, it is not an efficient approach. If you are sitting in an interview, remember first answer the brute force approach only. Okay, after that move to the efficient approach. So when you see O of n cube, you will definitely try to think the efficient approach should be running in O of n square. So how can I fit in some operations in the algorithm that I change this n cube to n square? The answer is, I hope most of you have got the hang of it. How can we do that? For that, what will we do? We will erase prod from here. We will eliminate this loop. Let me remove it. Yeah, we will eliminate this loop. Okay. Now, how will we calculate the required prod? If you can see, firstly, as our I was here and our j was here, correct? So first array was 2. The product for this is 2. Our I was at 0 and our j moved to 2, so the array was 2, 3, and the product was 6. So if you see, 2 and 6 have a factor of 3, and 3 is the jth element. Okay. After the 2, 3, minus 2. The product of all these is minus 12. And if you multiply 6 with minus 2, it will also give minus 12. So what you are saying, as we move the j and we multiply the element at j with the prod, we get the updated product of the new subarray. So what I'm saying is, instead of keeping prod inside of the loop with the j, keep it outside. Okay, and now prod will become equals to prod multiplied by arr of j. And after that, instead of updating it outside the loop, update it inside the loop. Max of prod start max of, sorry, this will be max of existing maxi with the new evaluated prod. Okay. At last, same operation return maxi. I hope the approach is clear to you. It is not that difficult to grasp. Okay. Time complexity will be of n square. The mission is accomplished. But still it is very much. Can we do it better? Can we reduce time complexity? Okay. If I tell you that you have to decrease the time complexity, from the n's cube, you thought, let me try to do it in n square. From n square, your thought should be, let me try to do it in O of n. You ask me, is it possible to do it in O of n? And my answer to that would be yes, yes, it is possible to do it in O of n. How? Let's see. So now, while looking at the optimized approach, I'll tell you that there are two types of optimized approach here. There are two optimized approach. One is using the observations, and second one is using modification of the pre-learned cadence algorithm. If you don't remember what is cadence algorithm, I will attach the link to the video in the description. Please make sure to watch it. Okay, modification in cadence algorithm. If you ask me my personal favorite, observation one is my personal favorite, and this one is also good. A competitive programmer or a DSA expert can think of it, but this is not that observation. And if you answer with this question, this approach in the interviews, it is not going to help you gain points. This approach will create an impression of you as a problem solver, but this approach will create an impression of you as a crammer. Okay, so how to approach this problem? Okay, observation. Let me deduce the observation first. Okay, so observation states like, observation says, what are the types of array you have? Possible types of array. First can be all positives are present in there. All positives are present. That is, the array only consists of positives. No zero, no negative, all greater than equals to 1. In that case, what should be your answer? If all the positives are present, your answer should be multiply all of them and return. Multiply all of them and return. Correct? I don't think I have to give example for it. You can think of it. Okay. Second one, even positives, even negatives, sorry, and rest other positives. Pay attention, negatives and positives and zero are different. Okay, I'm not including zero in positives or in negatives. So, what does even negatives mean? Even negatives mean that the number of times a negative number is coming in the array is even. That is 2, 0, 4, 6, 8, 10, etc. And all other elements except those negative numbers are positives, not zero, greater than or equals to 1. Such as the example for such an array is 2, 3, minus 1, 6, minus 4, 8. So if I ask you what is the answer in this case, if you use the basic mathematics taught to you in 6th class, you will see that if I multiply minus 1 with minus 4, the minus minus will got cut and changes to positive, and the answer is similar to the first test case, that is all positives are present. So the answer will remain same here also. Multiply all of them and return. I hope I am clear. It is very clear up till now. Now come to the slightly difficult part, not much difficult, slightly difficult. That is, we discuss even negatives, now odd negatives. Odd negatives and rest others are positives. Odd negatives means there can be 1, 3, 5, 7, etc. number of negatives in the array. One such example is, let me make it for 3, that is 2, 3, minus 1, 4, minus 6, 7, 8, minus 3, and let me mark it 12. Okay. If you see, this is a negative 1, this is a negative 2, this is negative 3. Three negatives are present, that is odd number of negatives are present. How should I approach this problem? Okay. How should I approach this problem? If I try to use multiply all the elements and return, I will fail here because we want to find the maximum. Our objective is to find the maximum, and multiplying a maximum with negative will turn it into minimum. So that is not a good answer. We have to think another way. How can we think? So it is definitely true that we have to skip one of the negative integer to keep our answer as maximum. So what can we say? We have to skip one of the negatives to achieve our goal. Yeah. Just to be on the same page, are you able to understand that we are only going to skip one? Why one? Because on skipping of one, the odd will turn into even, and then we have to answer as we did in the second test case, that is even negatives and all positive, that is multiply all them. So if I'm skipping this one, for example, I can skip this one. Let me make it, let me analyze it. If I skip this one, if I skip this integer, how many subarrays are present now? This one, okay, and this one, okay. What can I do? I will calculate the sum of product of these two and these all, compare whose is maximum and return. Correct? Okay, correct. Now, if I discard this negative, possible subarrays are this one and this one. Okay. Same case. And if I discard this one, possible subarrays are one from the starting and the remainings. Correct. So think intuitively which are the options that I can discard. These are the options 1, 2, 3. I hope I'm clear up till now. Here comes the difficult part. Which of these three should be discarded so as to find the maximum answer? Now, if you see, if I discard this one, will this subarray be negative? Product of this subarray be negative? Yes, because if you see in the left subarray, this one, there is only one negative. That is odd number of negatives. That it will remain negative. Similarly, in the right subarray, only one negative, so it will also remain negative. Okay. So I have to discard the option number two. Correct. For option number one, you can check if I'm discarding this one, then I can get two negatives, that is even number of negatives. Okay, so this is a valid option. This is not a valid option. Coming to the third, if I discard this one, again two of them are left as negatives, so even number of negatives. So I will have to use this also. So what is my approach saying? That either I have to discard the first negative or last negative. Hope I'm clear up till now. Are we on the same page? For the correct answer, I have to declare either the first negative or the last negative. Correct? Okay. Which one should I discard? Okay. The decision will be made based on the product values. The decision will be made based on product values. That is, keep product count from here and keep product count from here. Okay. Which one is the maximum? Whichever one is the maximum, update your answer and return. Okay. So I think the third observation is also handled. Okay. Coming back to the last and the most important one. And I will solve it very intuitively, very easily. You will observe. Okay. So coming to the fourth one. We discussed all positives and both types of negative, that is even negatives or odd negatives. Okay, negatives with positive, correct. What if what if zeros are also present? This is the case, zeros are also present. Okay, example of such a subarray is 2 3 minus 4 2. Okay, 0. Okay, 6 5 6 4 minus 5, again a 0, and 3 2 minus 3, again a 0, and 1 12. Okay. Okay. What are the sub-arrays now? You all can see sub-array is a contiguous part of an array. Okay. Now, if I have a greatest product in my hand, and if I multiply it with 0, will it remain the greatest? No, it will turn to 0. Okay. So what can I say? I can say that no sub-array will include 0. Correct? No subarray will include 0. No subarray means no answer subarray, in the sense no answer subarray will include 0. The answer subarray cannot include 0. We will have to skip the zeros. So how can we proceed? I'm saying that what we were doing in the case of the odd negatives, we were starting a count from here, product from here, and starting a product from here and updating the maximum likewise. Correct? I'm saying whenever you encounter 0, you encountered a 0. Suppose I'm keeping count a product as x here and y here. Okay, so whenever I encounter 0, my x becomes 0 here. Now when I move to the next element, I will start from x equals to 1 beforehand, and now my new product will be x equals to 1 into 6, that is equals to 6. Okay, again I encounter 0 here, x will become 0. Again I change 0 to 1 and then start. Again I here x equals to 0, change it to 1 and then start. Similarly for y it will become 0 here, start, make it 1, start. 0 here, make it 1, start. 0 here, make it 1, start. Okay, this is my approach, that whenever I encounter 0, I reset. This is the golden line here. Whenever I encounter 0, I reset my product values. Am I clear? Am I clear? Say it to yourself. Am I clear? If I encounter a zero, I reset and then continue. Okay, and continue updating my answers. Okay, this is my approach. Okay, in the case of zero, the potential subarrays can be one, two, three, four. Okay, let's try the pseudocode real fast. The video has been becoming long. Okay, let's write the pseudocode now. Pseudocode says initially your x is equals to 1 and y is equals to 1. Correct? Initialize your answer as int min, because whenever we need a maximum, we initialize as int min, so that using the max operator can be easy for us. Then for I going from 0 up till n minus 1 actually, if x is equals to 0, change it to 1. All right, and then x will become equals to x multiplied by arr of I. Okay, and answer will get updated. Answer will be equals to max of our existing answer with updated x. Okay, the loop will end. Similarly for y, but y will start from ending, so it will start from n minus 1, go up till 0. What are the steps? Same steps, but just as x will changes to y. If y equals to 0, y will become 1. Y equals to y into arr of I, and y, oh sorry, ans will become equals to max of ans y. At last, after the complete execution of both the loops, return your answer. I hope the pseudocode is very clear to you, and pseudocode will only become clear to you if you have understood the approach. Okay. So if you have any doubt in the approach, play the video twice, and if it is not getting solved either, I've mentioned the Discord link Discord server link in the description. I hope the pseudocode is clear to you. The pseudocode will only get clear to you if you have understood the approach correctly. Okay, and if there is any problem with the approach, please feel free to contact me on my Discord server. The link has been provided in the description. Let us analyze the time complexity for it. As you can see, n times this operation, n times this operation, so it will be O of 2n, which can be mentioned as O of n. And here we are not using any time of space complexity, so space complexity will remain O of 1. Okay, done. Let's move to the code real fast. The pseudocode we have written is very much helpful for writing the code. So let me initialize our x as 1, y as 1, and our answer as int min. Now for int I equals to x, int I equals to 0, going up till going up till equals to n minus 1, I plus plus. Let me zoom it for you more. Yeah, I plus plus. If x equals to 0, x will change it to 1. Okay, now x equals to x star arri. Okay, now ans will change into maximum of existing answer or x. Okay, let me copy it down for y. I will just change the loop conditions and x with y. I will start from n minus 1, go up till 0, and without instead of plus plus, minus minus will be used. Change all x with y because all the steps are same. Now here y. After that, return your answer. Okay, let us try to compile and run it. Hope it works. There has been a mistake. Yeah, I'm not put at the semicolon. Yeah, compile and run. Working fine. Okay, let's try to submit it. Running fine. Okay, now please hold your horses because I'm going to explain you the second approach. That was the modification of the cadence algorithm. All right. All right. So the second approach works like we have got an array. Suppose our array is 2, 3, minus 2, 4. Correct? We keep two products, that is the maximum and the minimum. Okay. What does the maximum store? It stores max of existing maximum multiplied by ARRI and the new element ARRI. Okay. And it stores the minimum of existing minimum into multiplied by ARRI or the new element. Okay. Now, this is the first thing you have to do. Second step is if the new element is negative. In that case, swap maximum and minimum with each other. And third one is your answer will be max of your existing answer and maxi. At last, after the loop ends, your return answer will be executed. What is the approach here? The approach here is we keep two pointers, maximum and minimum. Maximum contains the subarray with maximum sum up till now, maximum product up till now, and minimum will store the subarray with minimum product up till now. Now, suppose you have a maximum sum as 6 up till now and minimum sum as what do we say 4. Okay. If I encounter a new element that is minus 2, I multiply 6 with minus 2, it becomes minus 12. Okay. Multiply 4 with minus 2, it becomes minus 8. Initially, it was greater, it was smaller. Correct. Now, it is greater and it is smaller. So, we have swapped the value of those two. It will become minus 8 and it will become minus 2. That is why I answered that you have to use approach 1 at the time of interviews, because this approach is not that much based on the intuition. It works fine for all the test cases. I will show you the code also. It works fine for all the test cases, but no one can think of it. Means I cannot give a conclusive proof that it will be correct always. All the test cases are running, that is another thing. Okay. So try to go by the first approach. That will be more beneficial for you, for your understanding and for your interviews as well. Okay. Without wasting any time, let's do the code. Yeah, so what were we doing? We were keeping two pointers, long maxi equals to the first element right now. Similarly, minimum equals to first element, and our answer is also equals to the first element. Now, running a loop from the first element, from the second, for int I equals to 1, because we have already counted ARR of 0. I will go up till last element, I plus plus. Now, if ARRI is less than 0, so we have to swap this two. Swap maxi with mini, correct? Yeah. Now, if maxi multiplied by new element is less than the new element, then maxi will be equals to new element, else maxi will be equals to existing maxi multiplied by new element. For mini, just have to change the inequality and the variable's name, else all will remain same. So I'm using a control C control V. That is our engineer's choice. Mini multiplied by RRI is greater, so mini will be RRI, else mini will be okay. And at last, your answer will be max of existing answer with maxi, and then return answer. Running the compile and run, working fine. Try it out for submit also. Working fine. Okay. This was all from my side. I hope you like my video, you like my content, and you like my effort. If you have liked it and wanna see such more, please don't forget to subscribe and hit the like button. And keep coming here for more such contents. And keep hustling, keep struggling. Have a nice day. Goodbye.